Hmm. Hello everyone, I welcome you all to the next event of AWS UG Jaipur, and we have a very special guest today. So before jumping to the session, I would like to introduce our community partners, that is Docker Jaipur, AWS LPU community, 𝐸𝐵, DevScript and Student Coding. Okay, so what is AWS UG Jaipur about? So this is the official group of AWS UG across Rajasthan. So you can join this. There are already our socials in our description box. LinkedIn, join our Slack channel. So what's this about? This is the official community group of AWS and cloud computing enthusiasts, passionate developers, architects, users, and evangelists, and students to share their ideas, knowledge, and experience in and around Rajasthan, India. So if you are not from Jaipur or even Rajasthan, so there is no boundary that you can't join this group. It's open to all. So we are happy to have you. You can join us anytime. Yeah. Okay. So. Um, So about this workflow, about this session, we have a quiz at the end. So make sure to do the quiz, participate in that quiz, and we have swags to give away and also one-to-one mentorship. Okay. Next is there is another contest about knowledge share that is based on your LinkedIn post. So whatever you learn in this session, you have to share on your LinkedIn post, tag us and tag Suman, our speaker, tag all of us, and we will decide that whose post is the best, and we will have the one-to-one mentorship with the speakers or us, the industry experts. Okay. Um, Few of the suggestions of a good LinkedIn post is you can share your learnings, tell us a unique thing about the session, and take a screenshot of the session. Okay. Now, okay, it's time. So we have a wonderful speaker. Let me add him. Hello, Suman.
Hey, hi everyone.
So I would like to introduce you first. Yeah. So Suman Debnath is a principal developer advocate at Amazon Web Services based in India. He is passionate about big data, machine learning, and deep learning. Prior to joining AWS, he worked at various organizations like IBM Software Lab, EMC, NetApp, and Toshiba, where he worked with system and performance engineering teams, focusing on storage protocols like FC, NVM, EOF, and performance benchmarking and tool development. So, Suman, would you like to add more to your introduction?
No, thank you so much. I mean, you said more than what I actually did. So, thank you everyone for joining in. Looking forward to share a few of my learning and look forward to learn from you all, not only from this session, but going forward. I can see a lot of people I already know and happy to connect.
That's awesome. So, maybe you can start the session now.
Sure.
Okay.
Okay, so let me first share my screen. Yeah, so I hope the screen is visible, right?
Yeah, it's visible.
Okay, cool. So, firstly, thank you so much for joining in. And what we are going to do is, we are going to look over how serverless looks like. If you are new to serverless or you have been working with serverless, there will be something that you can take away from here. And the idea is to give you an intuition of what serverless is, especially for folks who are very much new to serverless. And then we will touch base on few of the services that you can make use of to build some application of your interest. And then towards the end, we are going to deploy all of this using some framework, right? And we will look into that, how we can do it manually, but that is not a preferred way, and we will learn that why it is the case. And then we will wrap up. So there will be some demos which will be provided to you. You can play around, you can build on top of it. Yeah, there are tons of resources on this field. So we will discuss all of that. Okay. So while I'm presenting, I'm not able to see the chat. So what we are going to do is we are going to take questions towards the end, or if you have any questions, feel free to pop in the comment. Someone from the team will highlight that, and we will discuss that. Okay, so that's the overall idea of our session. So but I really want to make sure that you are not wasting your time here. So in case you feel that this is getting very boring or something like that, just stop me, and I would urge the organizer just to shout out and stop me there itself, so that we can move on to something which is more interesting. Okay, because I really value your time, and we are not here to see some dying slides. So there are a few things that I want to cover within first 10-15 minutes, and then we will get into the hands-on part. Okay, so let me put that in the presentation mode and see how it looks like. Okay, can you see the screen? I mean, full screen.
Yes, Suman, we can see your screen.
Okay, perfect. Sure, thank you. So when we think about serverless, right? So for time being, we can just forget about what serverless is, and what we can go over is how we used to deploy an application, or how we used to build an architecture for any software development. So this a lot of content here is developed by Eric Johnson. So he's a principal developer advocate at AWS. He's one of my colleagues, and I really want to give him a shout out, because he built a lot of interesting demos, and I'll share a few of these links as well, because he's majority of his work he do on the serverless side. So you should look out for those resources as well. I'm going to share that later, but what we are going to do now is we are going to see how an application is developed, in a traditional way. So if you look at it, you will be starting off something like this, right? So you might have an idea and you want to build that. So what you will do is you will buy one server, or you will ask for one server in your company or in your college or wherever it is, and it may be your laptop as well. And then you will deploy everything or build everything on that single machine, right? Maybe proxy servers. You will write your own code there, the actual business logic, database, everything in one particular place. Now, if you look at it, this is not a very scalable thing, because in this, if this server goes off, everything goes off. If proxy doesn't work, then everything will crash, right? Nothing will work. So how you move ahead from there is you kind of break these pieces, right? So you break this proxy in a separate server, and then you have your code and server or client in one single place, and then you will have your database. You can even go further, and you can split the server into front-end client and the back-end client, and then you will have a database. So now this architecture works fine, because every piece is independent to each other. But
Suman,
you can see, yes.
sorry to stop you, but I think
Is there any question?
I think your screen is not in full screen mode. So there are some display settings.
Okay, that's why.
Yeah.
Okay, just 1 second. That is what I was asking. Yeah, 1 second. Huh? So, is it now okay?
Yeah, it's perfect. Yeah, it's perfect.
It's perfect. Okay. Yeah, sorry about that. So now what you have is you will split your components in different servers. So now you will be in a place where you will have your proxy separately running, client separately running, database separately running. So all is working fine in this tiered architecture. But you can imagine that if again one of the component goes off, everything goes off, right? It's just like different compartments of a train, right? So if something happens in the middle, everything breaks. So to mitigate that, what you can do is you need to have redundancy, right? So to add redundancy, you need to add servers. So that's why you see that there are two servers for each of these layers. So this is working pretty okay, right? So if you imagine how we started with single server, then we went to tiered architecture, and now we added redundancy. So this is perfect, right? If you think logically, that you have load balancers, and you will have client, you will have backend and everything. So things are pretty okay, at least at this stage. But what happens is, when your application traffic goes on, you will need more and more servers, right? So you will need to add more and more redundancy, because there will be a point when these two servers may not be good enough, right? And that's when you will try to scale out, and you will keep on buying more and more servers. Now the moment you add more and more servers, you will add more hindrance, right, to your administrative work, to your to your operational. So this will actually add your operational burden, right? Because you have so many servers to manage and all of this. So how we can overcome from here? Because this was the architecture which people have been using, and still a lot of people still use it, and it's perfectly fine. There is nothing wrong with that. But imagine that when you have to scale out, how much time you will keep on adding these servers, right? And most importantly, who will manage all these servers? So how can we approach this problem in a much better way? So we can make use of containers, right? So if you are new to container, you can imagine a container is a next level of virtualization, right? If you worked in virtual machine and so on, this is actually a separate breed. So for those who are new to containers, you can imagine container as, when you have a physical machine, you have one operating system, and you will be running your application, right? But that has a problem, because the moment you need to have another application, you need to buy another server, then again you have to install operating system, and then you have to build your application. So what virtualization did was, they said that you can use a same physical machine, but you can just install some virtualization software on top of it, and then you can create small VMs. One VM might be of Linux, one VM might be of Windows, and so on and so forth. And then you can build on top of those VMs. But in that case also, to even start your work at the application level, you have to install some operating system, right? It may be Windows or Linux or whatever it is. So that's why people came up with container, which is kind of a next level of virtualization after what we all know about VMs, from VMware, Citrix, and so on. Now in containers, what happens is you take one physical machine, and that physical machine, or it can be a virtual machine as well, but let's keep our life simple, forget about cloud and all. I'm just talking about what container is, okay? So that you can better appreciate the value of container with respect to virtual machines. So what container is about is, you take a physical machine, you install one of the operating systems. So let's say it's Windows or Linux. So let's consider Linux, okay? Any Linux, you install it, and on top of it, you just have to install a container runtime. So for let's take an example of Docker, because that is the most predominant container runtime that we have. So just install Docker, and once you install Docker, you can create small containers on top of it. Now those containers are not virtual machines, because they are not running. You don't have to install an operating system to each and every container, okay? And just like here in this image, if you see, you can imagine that this is a physical machine, and this red one is one container, green one is another container, and this light green one is another container. But all these containers are not running a separate operating system, okay? So that means that you can just straight away run your code in these separate containers, because they all have a separate root file system, they have a separate memory management, everything is separate. So once you see what is happening inside a container, you will realize that each are kind of a virtual machine itself, right? But there is no overhead of installing a operating system on each of these containers, which was the case when you compare with any of the virtualization techniques that we used to have before, while we were talking about VMs. So now let's come back to our topic, where we were here, right? We were here where we had so many virtual machines around, and we are running our application. But now we are thinking of containers. So that means let's bundle that our code into a container, and then we can have client, backend, database, and so on. Similarly, if you want to scale, we can just scale the number of containers. So this is perfectly fine. There is no problem with this. But still, the moment you add more and more infrastructure, you still have to manage all these machines where containers are running, right? Because at the end of the day, container runs in some machine. So you have to manage those machines as well. Although we have some managed services, which we are going to see now next, but you still need to manage all those, servers. So with this, when you move, so this is a daunting, diagram, but we will try to keep it simple. Okay. So now, if you just see what we have here is, we have our load balancer, and as we said, in load balancer we need to have multiple instances. So that's why you have this clients in one AZ. So you can think of this as two different data centers, right? Two machines who is taking care of our client, and how the load will be distributed. Load will be distributed with some load balancer, right? So whatever traffic comes, it will distribute to multiple instances that we have in the client side. Similarly, in the backend, we will have another load balancer for the backend, and then we will have another virtual machine here and another virtual machine here, so that we always have redundancy, because that is one of the major concern for us. And then we can have some database. So in this case, we are using some relational database like RDS, but imagine some database. Now, this is about when we are talking about non-container world. The moment we come to container world, you don't have to manage all of this, although AWS will create virtual machines for you, but your application will be completely transparent. So your application will run on ECS. So ECS is our container service, where you can just create containers with the image of your choice, and AWS will create that physical virtual machine where your container will run. So you don't have to worry about the creation of all the machines where your containers are running, but still you need to manage them. So that's the problem that we still have. Even with containers, you still have to manage the scale, and you still have to make sure that how many machines that you have where your containers are running, right? So this is where the things like how you can save money in this, because in this case you still have infrastructure, and even if you don't use any of these, right, but you have to pay for it. So let's say there is no traffic in your application, but still your containers are up and running, right? And it has to be up and running, because you cannot make your application you turned off expecting that there is no one visiting your website in the weekend, right? You cannot do so. You have to be always open and wait for your customers to visit your website or your application. Now, this has a cost involved in this, right? Because you have to manage this infrastructure even when no one is accessing. And so how we can mitigate this? So just to revise what we have learned so far, we started with a physical or virtual machine where we have just one machine, and then we moved to multiple machines. So that is a tiered architecture. And then we tried to add redundancy, where we had multiple virtual machines for different layers like client, backend, and and the storage. And then we moved to a container, where everything is running as a container, but still those containers runs in some virtual machine. So that impacts the cost, right? So how we can scale and how we can make our application ready for everyone, but still save cost, right? And that's where serverless comes into picture. So what is serverless? So serverless says that these are the four key dynamics when we define serverless. You might have seen this text in n number of places, especially in AWS, that as it says, you don't have to manage or provision any server or infrastructure, right? So that means serverless doesn't mean that you don't have server. It's just like you don't have to think about it. Okay, so because at the end of the day, your application will run in somewhere, right? It cannot just run on the air. So, but you don't have to manage that. You don't have to even bother about all of this. So all your focus should be on your application code. Okay, so on your business logic. That's all. You don't have to worry about how my application will scale if 1 million users hit my website, or you don't have to worry about if no one is accessing my application, whether I'll be still charged or not, right? So you don't have to worry about all of this. So this will have a pay as you go. So the more you use, only when you will pay. Okay, so only when your code is running, at that time only you will be charged. If your code is not running, no one is accessing your website, you will not be charged. Okay, that's the whole idea of this. And then obviously auto scaling, and it's highly available and secure, and these are common practices across all these services when we talk about AWS in general. So now let's look into how serverless or looks like. So when we think about serverless can be we have different services when we talk about serverless. Okay, but based on these definitions, these 4 definitions, we can think of a lot of different services which are serverless. But to start off with, when you think about serverless, the first thing that comes to your mind is AWS Lambda. Okay, so that's the compute service which is serverless. Similarly, we do have a lot of database service which are serverless. Similarly, we have a lot of storage services which are serverless, and we will talk about all of that later point in time. But to start off with, when someone talk about serverless, that the immediate second thing that comes into our mind is AWS Lambda. But bear in mind that this is not the only thing, right? AWS Lambda is not equal to serverless, right? It's just one of the service which one gets started with. Now, how do we define Lambda? So let's look into this, and we're going to go to the demo, and then things will be much more clearer. Okay, so in Lambda, what happens is this kind of application is little different than traditional applications. Okay, so if you let's say let me give you an example. Okay, so let's say you are building a website, and your business problem is to convert let's say English text to, let's say, Hindi. Okay, so your objective is to convert an English text to Hindi. Okay, so that's the only business logic that you have. You want to build an application which converts English to Hindi. Now, a traditional approach would be you write your application code, right? It can be in C, C++, Java, Python, whatever, any language of your choice. And then you will create a front end out of it, and then you will host that website in some virtual machine or in some container, right? So now you will just wait when someone will provide that text in your website, and click on submit button so that it can get the Hindi text, right? So this is one way of doing it, and that is what the traditional way is. But when we think about serverless, imagine that if you have a flexibility or an opportunity in AWS or anywhere, for that matter, where you write your application code and keep it like that. Okay, you have written your code, okay, and you have just kept it like that, but you want that your code should get executed only when someone send that English text. Okay, that means sending that English text should work as a trigger to kick off your application, and that is what a serverless or a Lambda is. So you have to think about Lambda as a trigger-based service, right? So what do we mean by trigger? It can be anything. In this example, it was just a person sending a text, right? Maybe a person sending a text in the sense you can to put that in context. Let's say entry in your database, right? Or an file upload in S3 bucket. These all can be different triggers. So that means you have something in the client, and it will do something, and then that will trigger a Lambda function, and that is where your business logic is. And then the Lambda function will do its work, and once its work is done, it will just send that output to someone, right? It can be to the client, or it can be to some other place. So it may save that data in some database or S3 or wherever it is. Okay, so the idea is Lambda function is just like this. Okay, it will not see the what is happening around, but it will just sit like this quietly. But the moment some trigger comes, it will just wake up, and it will do its work, and it will put the output to the destination. So that destination can be any AWS service, okay, or that destination can be some third-party software as well. You can always integrate this with any third-party application or third-party providers. Now, the thing which is important is since we are focusing only on your application code, we have multiple supports of different languages like Node.js, Python, Java, C#. Even you can create your Lambda function in C++ as well, because we do support custom containers. So basically, you can even have a container, and you can create a Lambda function out of your container. Okay, so That is what Lambda does for you. Okay, so now you can ask how Lambda is doing this under the hood, right? So the under the hood, what happens is the moment you create a Lambda function, you can just all you have to do is you have to write your code, and you have to tell Lambda that this code is written in Java, or let's say Node.js, or let's say Python. So this is the runtime, okay? And you have to say that uh, you should run this code only one there is an object upload in S3 bucket name ABCD. So that code will only get generated when someone uploads an document or an image or whatever it is. You can define all of that in that in that particular S3 bucket. Okay. So what happens when someone uploads that document, it will trigger the Lambda function. And what AWS or what happens under the hood is it will create a container out of it from AWS. You don't have to manage, think about anything. It will just create an infrastructure for you in the backend, which is actually a container, and then it will execute your code. And once your execution of code gets over, it will just perish itself. So it will just get destroyed. Okay, so another intuitive thinking that you should have is, let's say you have triggered, or you have let's assume that your client or your event source is, let's say, an API gateway, right? Where you can just API gateway is our one of our service that we have to create endpoints, right? So and we are going to see that in action in the demo in next 5 minutes. But let's assume that you have written your Lambda code and it is there on AWS, and now there is one client which has triggered your Lambda code. That trigger can be anything, right? Just like I said, it can be an API gateway event, or it can be a database entry, it can be S3 upload, whatever it is. Just assume anything, okay? But the idea is the moment it gets triggered, this Lambda function will create a resource, right? It will generate some resource. And let's say to continue that whole process, to execute your whole code, it might take, let's say, 10 seconds. Just assume 10 seconds. Let's say the next request comes immediately after, let's say, 11th second, okay, or maybe exactly after 10 seconds. Then Lambda doesn't have to create another environment because it has already created that, right? So what will happen is it will use the same container to take the second request and keep on working, right? So the idea is Lambda will not create runtime environments for you if your trigger is coming one after another, and the time it takes to, the rate at which these events are coming is less than equal to the time it actually takes to execute your code. Okay, but what happens if, let's say, hundreds of people have requested exactly the same time, not per second, okay, exactly at same time? In that case, there will be 100 Lambda execution containers that will be created on AWS. Okay, and again, you don't have to worry about all of this, and that's why we say that you don't have to worry about the scale. So the moment all those 100 execution gets over, all the infrastructure will be perished. Okay, and internally what happens is when a container gets created because of one trigger, after the execution of that task, Lambda doesn't destroy that infrastructure immediately, because it just hopes that maybe some other request might be coming. So let's wait for some time, right? What is that time? We don't know, and we don't have to worry about all of that. If it feels that there is no work for me, I'm not getting the second request anytime soon, so let me destroy myself. If the second call comes, I will again generate, also I will again create myself. So this is the intuition that you should have. Okay, so with that in mind, I don't want to get into the more slides, but this is the last thing that I wanted to share is the different use cases, right? So we can think of these different use cases of Lambda. You can use as for web application, for backend, for data processing, even for IT automation. So IT automation is an interesting part because as we discussed, Lambda always works on triggers, right? Although that is true, but you can also use Lambda as a cron job, right? In IT automation, you do a lot of things, right? Like, let's say every night you will check if there is any system whose, let's say, port 22 is open. You have to just block that. Let's say every night you will check this. So those kind of things you can set in Lambda, so that you don't have to worry about scripting and all of that. You can just create different Lambda functions to do your task, and it will work as if it's a cron job. In that case, your events are getting triggered in a regular interval of time. All right. So the idea is with serverless, you can make use of anything which you want to execute, right? So it can be in your live production environment, or it can be in your backend for IT automation, or anything for that matter, right? So now one of the example that you can think of is you might have converted a lot of documents from Word to PDF or PDF to Word, right? So I still remember when I was in college, when I have to convert Word to PDF, I used to just search in the internet, and I used to get some URL, and I just used to upload my Word document, and it used to convert it into PDF, right? So imagine that application, that website is a serverless website, or an application that is serverless. So in that case, the moment a user uploads a document file, it might get saved in S3 bucket, and the moment it gets a file comes in that S3 bucket, it will trigger your application which you have written, which will convert that into a PDF file, and that container will go away, and that PDF file will be again uploaded into that S3 bucket, and that the user will get in response, right? So you can think about any application where you feel that your application code should be triggered based on some trigger or invocation. Okay, so that's the mindset that you should have. So with that, I'll just exit from this presentation mode, and I'll try to show you how we can create and a Lambda function. Okay, so this is the AWS console, and what we can do is we can just search for Lambda. This is one way to do it. Or if you just scroll down, you click on all services. In the compute service, you will find Lambda. So as we mentioned, right, Lambda is not serverless. So there are different services that we have which are serverless, which comes under different categories. Like for compute, Lambda is the serverless offering that we have. But in storage, we have services like EFS, which is a network file system. Then we have S3, as you all know. So these services are also serverless. You don't manage anything, right? The moment you want to use it, you just use it. That's all. Okay. Then in database also, we have services like DynamoDB, which is also a serverless, which is a key value pair store. And we also have Aurora. All right. So those all services are there, in different categories, which are serverless. So the idea is you should not consider serverless as only Lambda. Okay, that's why I'm just enforcing that point. So let's go to Lambda. And if you see here, I don't have any Lambda function now, right? It's 0. So what we can do is we can simply click on create function. So we are going to create a function using a framework later on, and because that is something that you as an engineer mostly would be working around. But to get started with, UI is the best place to create function. So you click on create function, and then you get lots of different options, right? So one is author from scratch, where you can give some file name, function name, give your runtime, and just create your function. And second way, which is actually the most preferred way to get started, is to pick up any of the blueprint, right? So here, if you see this S3 get object in Python, so you can imagine that what this function might do, right? So it might have a S3 client, and it will be reading some a bucket, whether if there is any object there or not. So you can search for whatever you want, and you will search, you will get something. So let's say if you want to do something with data analysis or data streaming, you can search for Kinesis, right? So you'll find lots of different blueprints with Kinesis, and you can search, get there. Even you can go for runtime, Python 3. See, we can get all different runtimes, framework blueprint. So let's say you are going to develop some application using Python. So you can just select the runtime and you will get some application or some blueprint with that particular language, right? And then we have containers, and that is what we were discussing, that you can even have containers running as an Lambda function, and this is we started to support this just last year at the reInvent, and you can explore this at later point in time. And then you can also browse from the serverless app repository. There are a lot of different repositories which are public as well as private, so you can just go ahead with that. Okay, so you can use this Alexa skill set with Node.js. So from the title itself, you'll get an intuition what this function would do. But the preferred way would be a blueprint, because that will give you a template kind of thing to get started. But for now, what we are going to do is we are going to use author from scratch so that we know that what is happening. And let's give some name. Okay, let's say foo. Okay, and then we can give some runtime. So let's go ahead with Python 3.8. And if you see, there are different runtimes available, right? Golang, .NET, Java, so on and so forth, right? And let's say, if you see here, there is no C or C++. So in that case, you may have to build your custom runtime, and that also you can do here, okay? And then what you have to do is you just have to click on create a function. There are other additional settings, but we are going to see that at later point in time, okay? So let's create this function. So if you see, now we got the function created, and it's foo, right? And if you see in the trigger, there is no trigger added because I've just created this function, right? And if you just scroll down, you will see that we already got a nice IDE kind of environment where we can edit our code. And it's already created a folder with the same name as the function, that is foo. And then there is a lambda_function.py. Why this is .py? Because we selected Python as our runtime. Now, if you double click on this, you can see that there is a small function written here, which is called lambda handler, and it takes two arguments, right? Event and context. Now, this is the place where you have to write your business logic, right? So, in the example that we were discussing, that uploading a document in S3 will execute your code. So, in that case, this trigger will have all the details about that object being uploaded to that S3 bucket, right? So this lambda function will get executed on that particular event, and in that example, the event is actually an S3 object upload, right? Now, how this lambda function would know about all the details about what object got uploaded, what is the name, what is the location, and all of that, these all things are captured in this event parameter. Okay, so this event contains all the information about the trigger. Okay, all the data that is that the lambda function should know about that trigger. Okay, and what this context is, context you can think about it as a metadata of that particular trigger. So it will have a lot of different attributes about that runtime environment, right? About that particular trigger. So most of the time, you will use this context object for debugging or printing, what are the different states of the trigger. But your function will be mostly around event, because this is the event which actually contains all the information about that trigger. So let's write some simple code and see how this all works. Okay, so imagine we are not going to add any trigger now. Okay, and we will see that trigger in some time. But assume that we are going to manually trigger. Okay, and when we do manual trigger, what we have to do is, let's say we expect the user to give their name. Okay, and we want to return the same name but in capital letters. Okay, that's all we want to do. Okay, so let's see how we can do. So we can say that data equal to, we know that everything will come in the event, so we can say event, and then let's say we expect a key inside that event as name. And what we are going to do is we just have to convert that into uppercase, right? So we can just convert it into uppercase. So my data, if the name is Suman, all in small letters, the data will contain Suman in all capital letters, right? And we can just update this return as, let's say, hello. Let's say we give some the name here. Welcome to the of serverless. Okay, so that's all, right? So if this event comes as a, it should come as a JSON or as a dictionary, and that dictionary should have a key as name, and I'm going to just convert that into uppercase, and we are going to just return this statement, right? Hello, Suman in uppercase, welcome to the world of serverless. So let's save this. Okay, now we can trigger that. So how we can trigger this? So we have to, as we mentioned before, we are not going to add any trigger, but we are just doing a testing, and we will be adding a custom test, like custom trigger. So to do so, we can just click on configure a new test event. So we can give some test event, right? So let's say test one. So this is just one random test, and we know that the key should have something like name, and we can give some name. Okay, so let's say 𝐶𝐮. Okay, and we can either delete this or we can keep it like this, because anyway this whole thing will go as an event, right? And we are not going to use any of these, so we can actually delete this, but even if it remains there, doesn't matter. So let's create this test. So now that we have this test ready, what we can do is we can test it. So let me click on test and see what happens. So as you can see here, it says that the test event is test one, but we are not getting the actual result, right? So because this is the same thing which we got before, right? I mean, in the template, in the default return call, right? If you remember, we modified this, right? But still we are not getting this. And the reason is this, because I saved this function, but I have not deployed it. And that's why it says that changes is not deployed. So this is also very important. You cannot just only save that function. You actually need to deploy it. The moment you deploy it, then it gets available for the future triggers. Okay. So now that we have deployed it, now let's go ahead and test it. And now we are getting hello 𝐶𝐮, welcome to the world of serverless. Now if you just go ahead and configure and edit this test to let's say Ryan, and click on save, and again if I just test it, you can see that it's working fine. So important thing to notice is the amount of time that it took to execute is just 2 milliseconds. So that means you will be charged only for that 2 milliseconds. Okay, although with the free tier and all of that, you will not be charged for millions of such requests. But I mean, there is a chart that how much request or invocation are free. You can check the free tier to get the exact number. But the idea is, imagine that this application was hosted in a container or in a virtual machine. It would have been running, the infrastructure would have been running as we are talking now. But in this case, this infrastructure no longer exists as we are speaking, all right? So although there is a caveat to this, as I just mentioned, since I have just invoked this Lambda function 2 seconds back, maybe the infrastructure is still there. We don't know. So maybe the moment we click on test, it is using the same infrastructure, but we are not going to be built for that. We are going to build only for the time your code was executed. Okay, so that's the idea about Lambda function. Now, let's talk about little complex things. Okay, so Lambda function has a timeout, right? Because you cannot just run a very long-ended process here for 1 hour, 2 hour, 3 hour, right? So I think as of today, the amount of time that it can execute is 15 minutes. Okay, so you need to make sure that your Lambda function, your code can get executed within 15 minutes. There are different ways that you can handle that. We have step function and other things where you can check the state of the function and all of that. But we are not going to that details. But the idea is, you can imagine Lambda function as your implementation of your business logic, which can be executed within this 15 minutes time frame. And another thing to note is Lambda, as you know, that the moment the execution gets over, the infrastructure goes away, right? So you don't get persistent storage. So for that, you need to use some database or storage in the backend, like DynamoDB or EFS, and you can use that storage, in your code, so that even if your Lambda function goes away, before it destroys itself, it saves the data in some persistent storage, right? So it can be a database, or it can be an file system, whatever it is, right? We have support for everything. Now imagine that if you have to have in your Python code, let's assume Python, and you are using some third-party library for your business logic. So let's say you are using a NumPy. So in that case, you will be using NumPy here, right? Similarly, if you use pandas, so you will have to use pandas here. So in that case, you will be adding a lot of dependencies. And for that, what we do in Python is you need to add an requirement.txt file, right? So you need to create a requirement.txt file, and put all of these, and then package everything in a zip file, and then upload that. Okay, you have an upload option as well here, as you can see. Also, let's say you are importing Boto 3. Okay, so Boto 3 is the SDK to access any resource in AWS, right? So as we know, so let me just open a console here. Okay, so let's go to the AI-based services. Let's go to, let's say, machine learning, and let's go to any of the AI-based services. Let's say translate, as we were discussing that, right? This is the translate service, right? And we know that these all AI-based services are API-based. That means all you have to do is you have to provide this text which you want to convert. That means, let's say, you guys. Okay, so let's say I want to translate this into let's say Hindi. Okay, so this is why it is coming. Can anyone explain? So this is what AI is, right? Let's see. Okay, so so the idea is, I mean, we are not talking about translate, but the idea is, let's say you want to convert a text into English to Hindi. So you need to call this translate API, right? So for that, what you need to do is, you have to install, you have to import Boto 3, and you might have to create a client, let's say Boto 3.client, and then translate. Right? And then you will be using this, let's say, whatever is the data is coming. So let's say you'll have this data from here, and then you will be using this client object here to translate. Right? And you will be saving this into some response. Right? But now in this case, it will not work if I just save this and try with some text. It will not be able to. If I just return this response, it will not work. And the reason it will not work is Lambda now need to talk to translate. Now it doesn't have the access to call a translate API. Right here, I'm able to run this because I've logged into my root account, and I'm actually admin account, and I'm able to run all of this. But here, the moment I test this, or the moment I trigger this, Lambda is going to execute, right? Not me. So Lambda doesn't have the permission to access or to call or translate API. So in that case, we need to configure the IAM policies for this. So how we can do that? We need to click on configure, and you can click on permission. And if you see, it doesn't have all the permissions to access the other services like translate and so on and so forth, right? So we need to add all those permissions into our Lambda function. So the thing that I'm trying to enforce is, when you do everything manually, from this console, or from your command line, or from your editor, let's say, you have to manage everything, packaging. You have to manage this IAM role policies, everything, right? So which is not a good thing, and that's where we need to use some framework. Okay, now there are different frameworks available. Okay, and the best framework that we recommend is to use SAM, okay, which stands for Serverless Application Model. So if you are aware of CloudFormation, or if you're not aware of CloudFormation, that's completely fine. So let me just go back to the console and search for CloudFormation. So this is the service that we have where you can write your infrastructure in code. So basically, it's an infrastructure as code service where you can just write a YAML file or JSON file explaining what are the things that you want to deploy, and AWS will deploy that. Now, CloudFormation is not specific to serverless. It can do everything that you can do manually or that you can do through some script or automation, right? So CloudFormation gives you a very intuitive way to build that infrastructure. But what happened is, due to this, lot of interest around serverless and a lot of complexity to deploy a serverless application when you build a very big application where different services talk to each other. In that case, it becomes very cumbersome to write a CloudFormation template. So that's why people came up with something called SAM. Okay, and what SAM does is, it is very much specific to serverless. Okay, but under the hood, the moment you create a SAM template, it will create a CloudFormation on behalf of you, equivalent code for CloudFormation in SAM. So if you search here SAM, right? If you search here SAM, you will not find SAM as a service. Okay, because SAM is actually it converts that template into a CloudFormation internally. Okay, and now what we are going to do is we are going to see a SAM in action. Okay, so it might so happen that you are not familiar with SAM. That's okay, but we are going to cover that now. Okay, and at future sessions we may have a deep dive into a SAM CLI. But now we will appreciate the fact how we created this Lambda function from here, right? We created this Lambda function manually. We added, we have not yet even added any trigger, right? So if you, one thing I missed to show you is the trigger, right? So let me just show you first. When you created this Lambda function through UI, there is an option to add trigger, right? So if you just click on add trigger, you will find all these triggers that we were talking about. It can be an API gateway, it can be an application load balancer, it can be S3, and so on and so forth. And it can be even some other partner events as well, like auth, whatever it is, right? Datadog and so on. So if you want to create a Lambda function of your own, everything manually, then you have to write your code, you have to add trigger, you have to add IAM policy, you have to package it with requirement.text, zip it, all those things that you have to do of your own. So imagine if there is a smarter way to do, where you can use a framework which can read from your code that, okay, this code needs an S3 access. So let me create an IAM policy for S3. Okay, this code needs an access to API gateway. Let me create an API gateway access policy. So on and so forth. So if someone can do all of this for you, then that would be great, right? And that is what CloudFormation, that is what SAM CLI does. So let's see how it works. So I have logged into my AWS Cloud9 instance, but you can do this from your virtual machine, from your laptop, desktop, anywhere. Okay, so people who are new to Cloud9, so Cloud9 is an IDE environment on the cloud. Okay, so basically this is an EC2 instance, but in that you also have a lot of packages installed, and you will get this kind of UI where you can you will get an explorer on the left hand side, and you will get a command line here as well. Okay, and everything is from the internet. So if I go to your home and if I want to show you, I don't have to carry my laptop. I can just open the Cloud9 instance, and I can start showing you whatever I want to. So what we are going to do is, this is a repository which we will share with you. You can play around. There are a couple of demos, but now we are going to focus on this order app demo. Okay, so first let me just clone this, if I can type it properly. Okay, so we have this. So now if you see left hand side, we got these 3 folders. So let's get inside this. EFS demo app. Okay, but before we do that, the only thing that we need to do is we need to install SAM, right? So I've already installed it. So if you see SAM, so you can see that the SAM CLI version is already installed. Okay, so there are three things that you need to do. First is you have to do SAM init. Okay, the next thing you have to do is SAM build, and the third thing that you need to do is SAM deploy. Okay, these are the only three things that you need to do in SAM at the very basic level. There are other things that you can do like local testing, all of that. We are not going into that details. We may have a SAM deep dive session, some meetup maybe next month. But these are the three things you can do. Okay, so let me show you how it works. So let's say I go SAM init and press enter. So it will ask me what type of project I want. So there are two ways. I can pick up any quick start template, or I can have a custom template. So let's go ahead with the quick start. Then it will ask whether it's a container based or it's a zip file based. So let's go with zip file. So now you can resonate what we are seeing in the UI and what we are getting it here. It's almost a similar widget that we are getting here, right? It's kind of an interactive way to build our serverless application. Now, what is the runtime? We want, let's say, Python 3.8. So let's click on 2. Okay, and now we have to give some project name. So let's say again, foo from SAM. Okay, and that's all. That's all we have to do to create an project. Now it is asking what template that we should create for you. So let's go with hello world, but there are different templates available, right? Like elastic file system one with step function, with event bridge, and so on. But let's go with hello world. So now you can see in the left hand side, we got a folder called foo-sam. And inside this, we got a lot of folders, event, test, and then there is hello world. Why the name is hello world? Because we selected this option. Okay, if you had selected a different runtime, let's say Java 8, you would have got a different set of application, because all these applications are different for different runtime. But that's not important. What is important to see here is if you go inside this folder, you already got an app.py file, and this is the Lambda function which you are going to deploy. And what happens is SAM creates a template.yaml, and inside this you can define all your resources. I'm not opening this because I'm going to show you for our project, but this is how you are going to create a SAM project. Okay, and once this is done, what you have to do is SAM build. And what SAM build will do, it will just package everything. It will read through your this YAML file, and it will package everything, and it will create a a zip file. And the moment you do deploy, it will just deploy it on the cloud. Okay. So now what we are going to do is we are going to delete this folder, because I just want to show you how to run this init function. So let me just delete this. Okay, and now we just have this folder which we copied from the Git, clone from the Git, and let's get inside this. And inside this we have 3 folders, and we are going to go to my order API. Okay, and in fact, what I did was I actually did SAM init, and I created this project. Okay, so if you see now, this also have events, and then it has test, and it also have a template.yaml. So before I show you what this is, okay, I want to show you what we are trying to do. Okay, so I'll just pick up the architecture diagram so that you can understand what we are going to build. Yeah, so this is very, we are not going to build a website. Okay, so this you can think of it as order app. Okay, this is a simple order app. So what we're going to use is, we are going to have an API gateway, we are going to have a Lambda function, and we are going to use DynamoDB table. And since it's an order app, we will create order, and we will have another API to let's say read orders. Okay, that's the only thing that we are going to do. But the idea to show is how you can use SAM to create all these resources through your code and also deploy this application on the cloud. Okay, so now let's go to our folder, right? So we are already inside this folder, right? And let me now click on template.yaml. So this is our template.yaml, and what we are going to do is we are just going to reduce all this so that you get what we are trying to do. Okay, so this is how a SAM template would look like. There are few jargons here, but nothing to worry. I mean, these are not that difficult if you look at it one by one. First two lines tells that this is a SAM template, because we learned that at the end of the day, it will get converted into a CloudFormation template, right? So these two lines tells CloudFormation that, hey, this template is not your native template, okay? So this is going to be a SAM template. You need to convert it into a CloudFormation template. So that is what this line tells us to do. Then you can give some description. So it can give any description. It's in just plain English. You can give whatever that describes your application. Okay. Now let me just minimize this. We will come back to this global part little later, and we will see that why we need this, global part. But for now, I'm just hiding this. So the next thing, which is the mandatory thing in a template, is resources. And this is the place where we need to tell SAM what kind of resources that you want me to create. So if you look into this architecture, we want three resources, right? We want an API gateway, we want a Lambda function, and we want a DynamoDB table, right? So let's first create this DynamoDB table. So for this, we have a table, and we are just naming it as order table. You can give any table name, okay? Foo table or 1, 2, 3, whatever, table 1, 2, 3. This doesn't matter, okay? So the next line, line number 17, we say that what we are going to do with this. So this is a name, but what type of resource you want me to create? So we are saying create a DynamoDB table, and the way that you can create is using this simple table format. Okay, and this you can read from the documentation. There are different types we have. If you want to create a function, it would be different. If you want to create a Lambda or DynamoDB table, it will be different, and so on. So this line says that please create a DynamoDB table, and these are the properties of the DynamoDB table. Okay, this is completely optional. If you don't give anything, then DynamoDB will create a table with ID as the default hash, okay, or the primary key. So because in DynamoDB table, you need to have a primary key. So here we are explicitly saying that the property of this table should be, it should have an ID as a primary key, and the type of that ID is number. It can be string or any other data type as well. Okay, so this is what we are doing in order table. So this 4 lines of code will create a DynamoDB table for you. Okay, so now let's minimize this, and now let's go to our architecture diagram. So we are done with this, right? So now let's create this Lambda function. Okay, we started from backwards, but you could have done it from API gateway, Lambda, as well as DynamoDB table. Doesn't matter. The flow doesn't matter. You can create wherever you want. So now let's open this read function. Okay, create order function. So since we are going to have 2 different activity, like one API to read the order or create the order, and one API to read the order. That's why we are creating 2 different Lambda functions. Okay, so let's open this create order function. So again, the type is a function, and that's why we are written here as function. If you remember, previously it was simple table. So this says that I'm telling SAM to create a Lambda function. Now the next thing we are saying is the property, right? And these are the property which will tell the details about this function. So first thing is, where is that code written? So I know that the code is written inside this folder, my order-app. So that's why we are saying that this is the path where you will find that code. And what should be the code name? If you see, I have a create.py and read.py, and this is a Lambda function for creating order. That's why it is create.lambda_handler. That means if you just double click, if I just double click on this, there should be one function called lambda_handler, right? So we will go over this little later, but let's go back to this template. So we have written the root or the actual place where it can find this lambda code, and what is the actual function that it should execute, right? And the last thing is here, this is the most interesting part. If you see, we are not creating an API gateway separately, because I'm still inside this this resource creation, right? If you see here, I have a order table creation, a lambda function for sorry, order table. So this is my table. If it is confusing, this is the table, okay, and this is the function one for create order, and this is another function. This is another function for reading the orders. So this is function 2, read orders, right? Now, if you look at this architecture diagram, there is no resource for API gateway, right? And the reason is this, because while we are defining this lambda function, inside that we are adding a trigger, and we are saying that this trigger is actually API gateway type, okay, and the path is orders, okay. This is the resource name that we are mentioning, and this should be a post method because we are creating order, so it should be a post method. And then we are defining a policy that when someone tells you to update an order, you should write that order to the DynamoDB table, right? So for that, you need to have access to DynamoDB table. So that's why we are just creating a policy where we are just referring that this lambda function can only read write in the table that we have created, not all the tables, okay? And that's why we are just referring to this order tables, okay? And automatically SAM will realize that this guy is adding a trigger as API gateway. That means I have to create an API gateway. So SAM will automatically create a API gateway for us. Okay, so that's why here we don't see an API gateway resource creation separately, because the moment I defined it this way, from the events itself, SAM will understand. So similarly, we will have a read order function where we will be having same function, same path of the code. The only difference would be the Python file would be different. It is now read.py, and that's why it is read.lambda_handler. So if you double click on this, you will find a function called lambda_handler. Okay, and lastly, this output, you don't have to worry about this output. You can just delete all of this. But when we deploy this, we will see the actual result of the endpoint, because API gateway will create an endpoint, right? So we are just trying to print that all of this. Okay, so you can ignore this. You can completely comment it, or you can uncomment. It's up to you. But this is not the important part. Important part is to show you this construct. Okay, how you can create a SAM template. These two are mandatory. Then you give a description, and then you give some resources, whatever resource you want. Now, lastly, I mentioned that we will discuss about global later on. If you see, I've created two lambda functions, but in none of the place I have given the runtime, right? So how would SAM know that this function is in Python? It won't be able to understand by this definition, right? So we should actually write here runtime is Python 3.8, right? Similarly, I have to run add this in the second lambda function as well, because both of them are lambda functions, right? So this is one way of doing. But since all the functions are having the same runtime, what I can do is I can just delete all of this. Okay, I can just delete all of this, and I can have a global section where I will just say that runtime is Python 3.8. Okay, so global is basically the construct which are going to be universal across all the functions that we create. Okay, so here we are saying about a function, but you can have a global for tables, global for some other thing, whatever. But the idea is you don't have to repeat everything in the consecutive code. Okay, just like how you use global variables in a lot of different programming languages. Okay, so that's about the YAML file. So let me close this. So we are not going to save this. I guess we have not tampered that file. Yes. Okay. So last thing is, before we start is, let's go over this read and create.py. So which will create an order and update the order. So how we are doing this? So let's first go over the create.py. So we are importing some modules, JSON, Boto3 and OS module, and we are creating we are reading the table name. And how we are going to get the table name? We are going to get this table name from the environmental variable called orders underscore table. And how it would come to know about this? If you go to template, in the global section, I've created a variable called orders underscore table. So the moment a Lambda function gets triggered, right, it will be created in some container, right? So that container will have this variable orders underscore table, okay, which it can read. And that's how we are just reading OS environment and reading that variable. And now comes the event and context, right? This is the Lambda function. So this is our table. We know what is the table and how we are creating a table client. We are using Boto3 resource DynamoDB. Okay, and then the first thing what we are going to do is okay, I guess I was into the create.py. I'm sorry. So what we are going to do is, we are creating records, right? So that means we expect the user to give some body, right? So we will read that body, and what we will do is, we will read each and every item in that body, and we will update the DynamoDB table using put item method. So put item method, what it does is, it will take each item and it will just write it in the DynamoDB table. Okay, and the message that we expect to send to the user is order created. So once this is done, later on, if the client sends a read request, we should be able to read it. So there are two ways client can give the read request. Either it just say read without giving an order number. In that case, we are going to scan the whole table and share the order details. Or if the user sends a particular order, then we are going to search for that ID, and we will check in the database whether any entity exists with that ID, and then we will just share that. Okay, and how we are going to do that? We can use DynamoDB conditional method called key. Okay, and that's how we are parsing this key as ID, whatever it is, and we are trying to give this user ID whatever user is giving. Okay, so don't worry about this code. This you can read about the documentation and see that how how a request from API gateway can be parsed. And if you ask me how I came to know that there should be something like a query string parameter, what I did was I initially printed event, and I read about the whole structure, and then I realized that whenever I'm sending ID, it is actually captured in this hash. Okay, and that's how I did that. All right, so now let's close this. Let's not save anything. Okay, so now what we can do is, we can just simply do SAM build. So it built the whole application, and if you see that it built and everything, it kept inside this hidden folder. So here hidden folder is not visible, but if you want to see that, you can click on hidden folders, and inside this you will find a build folder, and inside this you will find that there are two functions got created, and that is what going to get deployed the moment we do a deployment. Okay, so that's about this hidden file. Okay, so the next thing that we need to do is SAM. One more thing is, you can check the YAML file is correct or not by a command called SAM validate. Okay, so it will just go over the SAM template and say that okay, if everything is fine, or if there is any error, it will tell you right away. So then we can do SAM deploy. So when you do that for the very first time, you have to use -- guided option. Okay, guided, but or -g, whatever it is. Okay, and the moment you do that, it will ask you some questions. So let's do that so that I can show you how it works. So it will tell you what should be the stack name, because it is going to create a CloudFormation template. So I have executed before. That's why it is taking this name. So let's go ahead with this. The region you want to deploy, let's go ahead with the default. Let's click on no. And here we are telling Sam that create IAM role on behalf of me, right? So that's what that confirmation is about. And here it is saying it has detected that there are two functions called one function is create order function, and there is another read order function, right? And it is saying that this is not authorized because this is open to whole world, which is not a good practice. But for the demo, it's okay, and that's why it is giving a warning that you should add some authentication. Otherwise, your API will be visible to whole world, right? So for this demo, let's go ahead with yes. And similarly, it is asking for another function because if you remember, we have created two functions, right? And two API. If you to just recollect, we created two functions, right? Order create and create order and read order, and both of them had a API gateway involved in this, right? This is the API gateway, and there is also a different API, the same API gateway, but a different method, right? So that's why we are getting two times warning. But let's go ahead with that. Rest, it is saying that, are you going to say, do you want me to save all the inputs that you are giving me now? So let's go ahead and say yes. And that's why from next time onwards, you can just run this SAM deploy, and it will read everything from this SAM config.toml file. Okay, so let me just click. And now what it is going to do is, it is going to deploy that resource on AWS. And if you see, there is a file we got. And next time onwards, if you just run SAM deploy, it should be able to deploy it. It will not ask you for all those questions, because if you open this toml file, you will find all those names, stack name, and then what is the prefix, region name, and all of these are already mentioned here. Okay, so let me close this, and this might take a couple of minutes. And at last, I'll just show you how we can invoke from the API gateway, and we will be using Postman, which is a nice tool to send REST API calls to check, and we will see that how it works. Okay, so one more thing before we get to the questions is, I told you that this will create a CloudFormation stack, right? So now if you go here and in the CloudFormation, you can see that there is a stack got created, right, on my order app, and this is what the stack name I gave, and it is still in progress. And if you come to resources, you will see that you don't have to worry about all of this, which we were doing it manually, right? Creation of role. This is the Lambda function. There are two Lambda functions, one create order function, one read order function. It also created a table, right? All of this, it's automatically creating it. So we don't have to worry. So all you have to do is you have to wait for here to get this complete. But in the meantime, I can show you DynamoDB table, because I guess it got created. So let's go there. Give me 5 more minutes, then I should be done. I'll stop blabbering. Okay, so just 10 minutes, then we will pick up some questions. So if you go to DynamoDB and click on tables, you see that there is a table got created, right? And it has a primary key as ID, but there is no items here. If you see, there is no items. If you see, there is no items. Number of items is 0, right? So which is obvious because it just got created. We have nothing here. And if we just go to Lambda functions, and we see now there are 3 Lambda functions now, right? One we already created, that was manually, right? And 2 got created. One is read order, and another is create order. And it was postfixed with some randomness, like it just creates some add some random string to make it unique. And what we can do is we can just open any of this, and we can see that what it has added. If you see, it will just tell that there is an API gateway trigger attached. See, I have not done anything. Everything it has done automatically. You cannot see the source code here, okay, because we have done this from there, and it says that you manage from there itself, right? So because of hindrance. So you can avoid all those hindrance by editing here and again going to SAM and editing there, right? So that's the best way to manage your application. So everything looks good. So what we can do is we can just in fact last thing is API gateway. Let's go, we can search from here, as well as we can click on this API gateway, and we can see that we got an API, right? And this is the API we need to copy, right? This is the URL which we need to copy. Right? And if you just go to Cloud9, and we also get that this has been successfully deployed, and this is the output section, right? So we copied it from there, but we can always copy it from here as well. So now what we can do is we can open Postman, and we can do a read call. Okay, so I'm just pasting this URL, and we know that this is going to be a get API call, and let's send this. So as you can see here, there is no output, right? Because it's an empty list, because there is no data in that. So let's create some order. So let me click on create order, and this is a post API call, and let's paste the same URL. But now we have to give some data to that order, right? We need to give some data in the body. And if you remember, if you just come to this and create.py file, and you will see that we are giving the body, right? So, and it is going to read that data, right? And what we are going to do is, now we are going to come to body, and we are going to give some data, right? So remember that my DynamoDB table has a primary key of ID, so that's why ID we need to give. Without that, it won't work. And if you see, I have given ID, item name, let's say MacBook, price is something, let's say city is London, whatever it is, right? And then there is another item, and ID is 2, and this is a very famous book, Introduction to Algorithm, right? So CSLR, if you remember, I mean, if you are in college, you know which book this is, right? And you see this. This is the beauty of NoSQL database, right? I don't have category in this list, right? In this item, but I have category here, right? So that's how NoSQL database work. You don't have to have a predefined structure. So with this data, let's change this ID to maybe 1, just for better readingness, and let's send this and see what happens. Okay, so it says that order got created. So if that is true, then now if I just read, I should be able to fetch that data, right? So let's try to send a read request, and we can see the data here, right? So now, if you remember, in our Lambda function, in the read.py, when we are not sending anything, right, it is scanning the whole table, which just happened now, right? Because in this case, I have not provided any ID, right? Now, if I just provide some ID, let's say ID equal to 2, okay, then this part of the code should get executed, right? And I should get the details of only the item for ID 2. So let's try this. And now we are getting the only ID 2 details, right? So, and if you just give some ID which doesn't exist, again, you will not find anything in that, right? And lastly, if you go to DynamoDB table, and if you just refresh, you should be able to see those items here. Just getting refreshed, 1 second. So you can see these 2 items, right? We have just two items added, right? So there are a lot of things that we can do. We can have a post method, we can have a put method, we can have a delete method, and so on and so forth. And that's what I want you to do. Whenever your time permits, just clone this, play around this, change the template, change the code, and build different methods, and try to see how magically things happen on under the hood, without knowing about all of this. Lastly, I am going to share this link, and also there is a website called Serverless Land, I guess. Yeah, Serverless Land. So this is the best resource that we have to get started. So feel free to explore this. You will get a lot of videos, a blog post, and you can build anything around not only about Lambda, but other serverless services that we have talked about, like DynamoDB or EFS, and so on and so forth. Okay. So with that, I'll just put a full stop, and I'll just zip my mouth so that I can hear from you. So let me just unshare the screen.
Thank you so much, Suman, for the amazing session. And there was a lot of activity in the comments. Rohini was helping with the doubts, and we have lots of positive feedback that the session was great. And yes, I agree. And we have a few questions that I will ask. And
Sure.
so let me just start sharing that. So the first question is SAM work like Terraform?
Yes, kind of. So the SAM is basically for it's from AWS. It's an open source project. You can always go and contribute. With Terraform, you can do from different vendors and all of that. But SAM is very much native to AWS, and it's beyond serverless actually. So if you see, if let me just share my screen again. If you see in this SAM template, right? If you see in the SAM template, we have used all these functions which are native to SAM, but you can also use other resources which are there in CloudFormation. So in that case, it would be not serverless. It would be, let's say, EC2 or whatever it is, right? So those won't start with AWS serverless, right? So to answer this particular question, you can use any tool of your choice. Okay, we are not telling you to change everything and use SAM. If you are using a SAM, sorry, if you are using Terraform, just stick to that, right? So because using a framework is more important than actually selecting the framework, right? So but if you have multi vendors, then SAM should be the right Terraform may be the right choice. But if you are into AWS and do everything, then SAM would be very useful.
Okay. So the next question is from Amandeep. To confirm, we can run SAM from local machine too?
Yes, so you can do some SAM testing from your local machine. So there is an option called SAM local, but SAM local doesn't support all the functionalities. Like it supports API gateway, mimicking API gateway and so on and so forth. There are few services which you can test it locally, but there are few services which you won't be able to test it. Let's say you have in your serverless application, you have EFS as a function, right? EFS storage as a resource. Then you may not be able to test that function locally. But SAM works. You can always do SAM local testing, provided that your code has all the resource and those resources are supported by SAM local.
Great. Next question is also from Amandeep. What is the approximate cost of using Cloud9 terminal?
That's a good question. That's a good question. I'm not very sure about the price. I need to check for that. But you can think about that as actually it's an EC2 instance that is running behind. So you can check. You can pick some EC2 instance which comes in the free tier. So again, I'm not very sure about what the exact price. We can check that in the documentation and maybe share the right number.
Yeah. So next question is from Swapnil. What is best SAM serverless framework or CDK?
Yeah, these are tough questions. Honestly, I also don't. I don't know exactly what you should use, but I mean, since we have multiple options, the way that I always tell the developers is to see which one suits you the best. Okay, so if you just pick up these three, there are three different use cases for all of these three. Okay, at the end of the day, your objective is to do your job more efficiently. So whichever framework works for you, just go ahead with that. So if you compare these three, CDK you should pick if you want your developers only to build your infrastructure, because CDK we have support for different languages like TypeScript, Python, and so on, right? So you don't have to tell your developer to learn YAML, JSON, and all of that madness, right? So you can always tell them that, hey, you are already writing your code in Python. Why don't you use CDK? You can deploy your application of your own, right? Or there won't be that much of learning curve. So you can stick with CDK. And CDK covers everything, not only serverless. That's also one of the benefit that you have in CDK. But let's say you are only into serverless and you are using AWS for that. So in that case, maybe SAM would be a better choice, all right? Because it has a very native support for different services. You can do local testing and all of that. And you can also use third-party tools like serverless that someone just mentioned. That is up to you, all right? We also have a very good support for with these, third-party tools. And but it's all up to them. You should explore all of these before you freeze on something.
Great. Uh, Next question is, if someone wants to make career in AWS, which specialization could you advise him as an experienced user?
Yeah, that's a good question. I guess there are a lot of sessions around this hosted by Rohini. So I would maybe if Rohini or someone, if you can share that, that would be useful. But basically, if you think about AWS, it's basically IT in a nutshell, right? So there are a lot of things, and now you have to decide which is your interest area. It can be let's say serverless, it can be DevOps, it can be maybe a storage or compute, whatever it is. You have to pick that and build an specialization on that. So I guess that is more useful rather than floating across everything, because that is very overwhelming when you get started with it. And there is no such thing that that you should only start with this. But if you have to pick something, you may like to go ahead with one of the certification tracks, so that you get a maybe the solution architect track, which will give you an intuition of all the services and resources that we have, not from AWS standpoint, but also what cloud computing is about, right? And you will get a very good understanding of the whole breadth of services and how cloud works, basically. And then you can pick your specialization, right? So maybe serverless, then you can just focus on serverless. But start with a broader understanding, and then go deep into one of the track of your interest.
Yeah, I okay. So thank you so much. This is all for the Q&A. Rest of the questions were handled by Rohini. So thank you so much again, Suman, for the amazing session. Got lots of insights about serverless, and I hope the audience get to learn a lot, and they will share their learnings on social media or something. Yeah. So any last few words about AWS or serverless? Any good suggestions? Something.
Sure. So thank you so much for your time, and thanks Rohini for answering. Yeah, we got a lot of questions. Thanks for helping. And what I really want to share is, see, these events or these meetups are just a way to. It's a gateway to know people, and it should not. Your learning should not stop here. So feel free to reach out to
Yeah.
Abhineet, Seema, Abhi, Aditya, Rohini, myself, for anything that you need to get you started, or if you're already there, if you want to take your learning to the next level, feel free to reach out to us, and we will see how we can help. And not only this, we would really encourage you to come and share your understanding. You don't have to be an expert of something before you share. You can just come and just talk about your learning that you had. I think that would be helpful for everyone, including us, right? So I welcome
Yeah.
everyone to this user group, and thank you so much for all your time.
Thank you so much, Suman.
Thanks.
Yeah,
Thank you.
yeah, guys. So it's a time to just test our understanding what we have learned till now. And yeah, obviously, thank you so much, Suman, for such a wonderful session. And I'm
Yeah.
damn sure that every attendees will get a good exposure on serverless. So, and I'm afraid that the quiz will gonna be very easy for all the attendees because of the great explanation from Suman. So yeah,
Yeah.
let me just start this quiz. Okay. So guys, what can you do? Like you have to just put www.kahoot.it on your browser, be it a mobile or laptop, and you can just enter that game pin. And I request you all to just join with your real name, because quiz winner we will contact quiz winner and for that exciting prizes. So we
Yeah.
will wait for 2 to 3 minutes to join everyone. and that quiz will gonna be very much interactive, very much fun.
So people have already started joining.
Yeah.
So yeah, amazing.
Yeah, good
So
numbers
for
of
this
attendance
quiz,
participants. Yeah.
yeah. So for this quiz, you have to be really quick to get the highest points. That's a suggestion from my side.
Yeah,
If
and
you
yeah,
want to get
in
some
each
swag.
question you will get 30 seconds. We have extended 10 seconds because for the sake of that lagging, if anyone can
Yeah,
face.
yeah. I think 30 seconds is uh, enough for
Yeah.
a simple question.
Oh my god. 50 plus. What's that, JJ? I think we should proceed now.
Yeah, almost 90% are already there.
Yeah. Okay, last 10 seconds.
Yeah.
People are still joining. Cool.
I think we can start.
Okay, okay, Seema.
Yeah. All the best, everyone, for the quiz.
All the best, guys. Yeah. So the very first question is, you are using a serverless platform. So which one of the following you are not likely to do on serverless? It's a bit easy. Try to be quick as much as you can.
Yeah. For the highest points, we have some swags
Yeah.
for the winners.
Cool, cool. Oh,
Amazing. 31 were right.
oh, congratulations, Sabrinath. Wonderful.
Amazing.
So second question is, lambdas are monitored by default using which service? That's a pretty common question. I'm expecting 100%. Oh, cool. Wonderful, Ronald. Ronald. So how is the cost associated with lambda function calculated? This point is covered in Suman's session. I mean, every question is based on the session.
Okay, so some of you are wondering where are the questions. So you just have to use two screens, one for seeing the questions and the options, and other is for answering those questions. Okay, so I have already put it in the chat.
So which of the following is the customer's responsibility concerning the AWS Lambda service? Customer in the sense user who is using AWS Lambda.
And also, there is no lagging at our end. Maybe it's your network connection.
That's great, Ankit, for a big jump. Okay.
Yeah.
So what can trigger a Lambda function execution? This was told by someone multiple times. Okay, sorry to everyone who are facing lagging, but as you can see, we are getting answers, so we can't say that lagging is on our end.
Yeah.
So sixth question is Lambda allow for running or of what other things? Like what other things you can run on Lambda? It's a pretty tricky one. Nice.
44 were correct.
Ankit is leading. Yeah, cool, Ankit. Congratulations. So how can additional code or content be provided for your Lambda? It might be a tough one.
Awesome.
Ankit might be expert on Lambda.
Yeah.
What adds tracing capabilities to a Lambda? So what can you use to monitor function invocations? So this is the last question. What is the fastest way to get started with Lambda? I'm damn sure Suman has included this point also.
Okay.
So congratulations, guys.
John,
I
Anushka,
couldn't even
and
pronounce the name.
yeah,
And guys, whoever in case couldn't participate in the quiz, so we have another contest for you guys.
yeah,
Uh, yeah. So you the contest is that to share your knowledge on LinkedIn, and what you have learned in this session, you guys can share, just enhance your networking so that you guys can exchange your ideas with the world. So just a suggestion, like what you guys can include in your post, like tell us the unique thing about the session which what you have learned, and I would say share the screenshot, uh,
yeah.
the most good slide which you liked, and yeah, you can just post on LinkedIn, just you can tag someone so that we can trace you, and the best LinkedIn post will get setting prizes. We will contact you for sure.
Congratulations to the winners and everyone who participated. It's not like you didn't win, so that's not the end. So we will have future quizzes too. So yeah, do it in them.
Thank you everyone, thank you for joining.
Yeah. Thank you
Yeah.
so much for being a enthusiastic audience. There were like 100 plus members continuous for like 1 hour, so that was amazing. Thank you so much, everyone, for joining, and I hope you have learned a lot from this session. And yeah, um, we will have some amazing sessions in the future too. So don't forget to subscribe to our channel and share about this session on your social media. We would love to see your posts and tag us to all the social links of us. The organizers are already in the description box. So tag us, me. Seema Saharan, Aditya Soni, Ashutosh Saxena, and Abhineet Saxena. So tag us all, and yeah, tag Suman Debnath, Rohini, AWS UG Jaipur. So yeah, thank you so much. See you next time. See you in the next event. Yeah, bye.